Good evening to all of you. Today we have the second session of Organic Research webinar, and in this session we have very eminent speaker Sanjay sir. And let me first introduce to Sanjay sir. Sanjay sir completed his BSc from St. Columbus University College, Hazaribagh. Then he moved to MSc degree in organic chemistry from Vinoba Bhave University, Hazaribagh. Then he qualified CSIR JRF and joined as a research scholar in CSIR IICT Hyderabad under the guidance of Dr. Suresh. So today he will present his lecture on N-Heterocyclic carbene. Sanjay sir, now over to you. So start sharing your screen.
Sanjay sir, your voice is not coming, sir. Unmute first, sir.
Yes, sir.
You enable that one. Actually, that is disabled to screen sharing.
This thing, sir.
Give permission to Sanjay sir to share his screen, Subham.
Okay.
Same problem, sir. Are you able to see my screen?
Yes, sir, it is visible.
Okay. Sir, I start now. Yeah, we will wait some few minutes.
No, sir, you can start.
Good evening to all of you. And thank you, Subham, for giving chance to participate. Today's topic is evolution of carbene to N-Heterocyclic. Carbene and its applications in organic synthesis. Today's discussion is outlines. First, we know about the history of carbene, how carbene came in existence. Then later we discuss about the Benzoin condensation reaction, and later we know about the mechanical Benzoin condensation reactions by using thiamine catalyst. Then later we discuss about some synthesis of N-Heterocyclic carbenes, then isolation of NHC, and later we discuss some NHC catalyzed reactions. So here history of carbenes. How this we know well of carbene. I mean, this is the basic one, CH2 molecules. But we think how these molecules will synthesize. And very earlier, 1839, the scientists tried to synthesize CH2 molecules, not a carbene, because that time the people don't know about the electrons, and that time also not discover about the chemical bonding, all these things. But this time they try to synthesize CH2 molecules by decomposition of methanols using phosphorus pentoxides. But that times they are unable to isolate. They don't know about the stability of these molecules. Later, one reaction came in 1861. That times they using methyl iodide and copper to synthesis of methylene compounds, and they thought that CH2 molecule, CH2 intermediate is involved in the synthesis of these alkene molecules. Later, we know things, synthesis of carbene dichlorocarbenes by hydrolysis of chloroforms. Later, this is the very well-known reaction, Remer-Temer reaction. So using chloroformase and chloromethanes, dichlorocarbenes are involved in the synthesis of this salicylic acid. And these mechanisms came very late. I mean, 1949 onwards, their mechanism is came. Later, this is famous reaction, Buchner reactions to synthesis of the cyclopropenes molecules by using, again here, carbene is involved in these reactions. Later, Siemens-Smith reactions is also very familiar reactions to synthesis of cyclo. Tell me.
Now you are
what is this coming in?
Yes. Yes, you are host, so you have to also add the people which you are waiting.
Okay.
Yes, sir. So there are some people also invited room, so please add them because you are host of the meeting.
Okay, okay.
Also, someone is drawing on the screen. So who's ever drawn these figures, please erase these.
Okay, please mute all of you. Your voice, I mean mic, please. Yeah, fine. Hello. Subham.
Yes, sir, you start.
Yeah. And again, the Benzoin condensation reactions. In 1932, this cyanide catalyzed Benzoin condensation reaction, we know Uller and Lieberger discovered these reactions. Then the mechanism of this reaction came very later, 1903. This is the cyanide catalytic cycles. And after discovery of this, reactions, Ampollen's meaning, Ampollen term come in chemistry. This Ampollen is the German words, and we know Ampollen means the reversible of polarity, reverse the polarity. Later, this is the biochemical reactions. In this case, this is thiamine molecules, vitamin B1 and vitamin B1. This reaction is involved in the biochemical reaction to synthesis of acetyl-CO. And in this reaction, acetyl anion is involved. Later, 1943, Yugi was discovered the same reactions. They tried to do the reaction by replacing these molecules with benzaldehydes, and they expect to form these products, but they observe these products and benzoin products. Later, the mechanisms, how this reaction is happening, and this mechanism is solved by the Breslow, Ronald Breslow. He's given this reaction mechanisms. And initially, the people have thought that which part is reactive to involve these reactions, either H2 sulfur, this nitrogens. But after the deuterium exchange reaction, isotopic labeling, they found that this C2 carbon is rapidly exchanged with the deuterium solvent. And this Breslow is given the mechanism of that benzoin condensation reactions. That is the first NHC catalyzed benzoin condensation reactions. In these reactions, how this thiazolines molecules react with base and form this anion. And this anion undergo conjugations with this one, and this form the lone. This is the lone pair electrons. And these types of carbene, basically N-Heterocyclic carbenes, are always nucleophilic in nature. So From here we can see this NSC is nucleophilic in nature, and this attack on the carbonyl center of benzaldehydes and form this intermediate, and and form these types of intermediate. This intermediate is known as Breslow intermediate. This tetrahedral, again this intermediate react with another molecule of benzaldehyde and form this intermediate, and this intermediate again this anion undergo here and the removal of NSC and form the benzoin products. Later, the mechanism of these reactions, we know this intermediate is highly reactive, and means we can consider this is the highly reactive intermediates, but no one is trying to isolate these ones. Due to these reasons, if carbon is formed, it is highly reactive and it forms the dimer products, so it is not possible to isolate these molecules. But in 1968, two groups are isolated, but in this case, this is the metal ligands. They are not isolated in a pure form. It is in the form of metals ligated. After the discovery of this metal ligated carbenes, the carbenes becomes very popular as a ligands. I mean, it is a very good sigma donor ligands. And after that, several years, work on that area. Still, the working is working in progress. Carbene act as a ligands, and we know one very good reagent, Grab's catalyst. That is in that catalyst, NSC act as a ligands. And later they tried to that. 23 years, no research happened on NSC as a NSC act as a catalyst, but Ardungo groups are isolated these carbenes. First, after the isolation of these carbene molecules, one another argument is came. The people have said that this NSC have very bulky, that's why its molecules not undergo dimerizations. But later, these groups again isolated from carbenes. That is, that molecules have no any hindrance molecules, they are bulky molecules. How these molecules are stable due to the synergic effect. Here, lone two means when vacant orbitals and one filled orbitals is there, and this nitrogen containing the lone pair. So due to back bondings, here we can say synergic effect. These molecules are stable. Now we discuss about the in NSC reactions. Basically, these four intermediates are involved. First, Breslow intermediate, other is extended Breslow intermediate, and as a Breslow intermediate and deoxy Breslow intermediate. When aldehyde is react with carbenes, this form Breslow intermediate. If alpha beta unsaturated aldehyde react with carbenes, then form extended Breslow intermediate. If imine react with carbenes, this form as a Breslow intermediate. And if Michael acceptor is react with carbenes, known as deoxy Breslow intermediate. So here I discuss about these two reactions, these two famous reactions, reactions. The bases react and form carbene, and this carbene react with and this intermediate. Then again, aldehyde is react another partner. If is another partner, it's form 1,4-diketones, and this reaction is known as Stetter reaction. So I already discussed some benzoin condensation reaction previously. Now I have discussed about some Stetter reactions. Here this is intramolecular Stetter reactions for the synthesis of dibenzoxypins and thioprins. Here NSC is react with first. You can see mechanism from here. Here NSC is react with this aldehyde and form this intermediate. Now this intermediate form Breslow intermediate, and this intermediate reactions and form this intermediate. Now undergo the removal of NSC and form this dibenzoxypins molecules. Later extended Breslow intermediate. These are the extended Breslow intermediates. Reactions for the synthesis of 7 and 5 numbers cyclopentenes. In these reactions, the mechanism is like that. NSC is react with and form this intermediate. Again, this intermediate undergo proton to proton transfer and form this Breslow intermediate, and this is known as the extended Breslow intermediate. Then this extended Breslow intermediate is now undergo for conjugations. With this lone pair, you can generate here anions, and this anion will be again undergo for one electrophiles and form here, and this intermediate again react with another nucleophile. I mean undergo tautomerizations and found this carbonyl. In this carbonyl, we have removal of this NSC by this nucleophile and form these types of products. So here, at a time, we can add one nucleophile, one electrophiles, and form several types of reaction. I mean several types of molecules you can synthesize by using this extended Breslow intermediate. Later, as a Breslow intermediate, in this case, the 2,3 disubstituted are synthesized by our groups. Continuously, which groups are also synthesize these molecules by using different catalysts. This catalyst is used by our groups, and this is the PG groups. How this reaction is happening? Again, this imine undergo ambulance, I mean reversible of the polarity, and this anion is formed. Then this anion undergo Michael addition reaction, and again the aromatization and form this reaction. I mean this product. Later, Biju again given one method to synthesis of as a flow here, anion is formed by column of this imine, and this addition, you can so addition reaction, addition reaction, and remove followed by the removal of the chloride, and form that quinoline molecules. Now deoxy-Breslow intermediate. Here, basically this Michael acceptor is electrophilic in nature, but if you react with NSC, it becomes the nucleophilic in nature. And again, this undergo SN2-like reaction and form this cyclopentene rings. The mechanism involved like that. NSC is react with this Michael acceptor and undergo 1,2 here proton transfer and form this anion, and this anion again undergo SN2-like reactions, followed by the removal of this NSC from these types of 5-member ring. Conclusions: the NSC is mainly very stable molecules due to electronic effects, and NSC used as a ligand, substrate, catalyst, and NSC is viable to synthesis of several reactions. Thank you very much for your kind attention.
Thank you so much, sir, for your presentation. Now, this presentation is open for question answer discussion. Please go to slide number 12. Catalytic cycle, actually. Yes, sir. So please explain this catalytic cycle.
Actually, this act with base, and carbene is formed in situ the reaction, and basically this carbene is nucleophilic in nature, so it will react on aldehyde, and this aldehyde, after reacting this one, this anion again abstract this 1 to protons and form these types of intermediate. This is known as Breslow intermediate, and this is nucleophilic in nature due to this electron pair of nitrogen 1 electrons by moving here, and this pi bond shifted to here like a Michael addition reaction like. And then again this proton is abstract by anion, and again here anion is generated, and this anion undergo by removing of this catalyst and followed by the generation of our products. It's clear?
Yes, sir. Any other question?
Yeah.
I think no question. So thank you so much, sir, for your presentation and time. And thank you so much, all of you, to join this
Yeah.
seminar.
Thank you.
And now we will meet next seminar. Thank you all of you. Now you can leave.